All right, we can go. Well, 2 days come to an end here. A couple of presentations to be done. Thanks for joining in here. My name is Andy Falkner. I'm the engineering director for Pluribus Networks in Europe. I'm going to pick up a topic which has been talked over and over today. It's about whiteboxing, and it's about, hey, how can we accelerate the use cases for whiteboxing? I'm working for Pluribus Networks. Now, some of you might not have heard of Pluribus Networks before. We're a network operating system, SDN OS provider for controllerless networking. We're running on whiteboxing. We're very fond of the open networking initiatives, partnerships with Dell, obviously EdgeCore. We're running our operating system on the Ericsson platforms on Celestica. So we've got a broad kind of hardware coverage on our initial scope. Now, today I'm going to talk about how do we take the whiteboxing idea into the edge, into the routed environment. And I'll give you some of the backgrounds and kind of some of our thoughts, how we kind of approach it. So this presentation is actually, we want to use cost-effective ways to build high performance or to use high performance routing capabilities, provide multi-tenancy, slicing capabilities, especially in the cloud area. And actually, it was initiated, it was kind of an engineering, but very strongly driven from customer side. We've been dealing with a cloud hosting provider here in Europe. And one of his asks was, because of the scale, because of the hyperscale and all the requirements we're currently putting on our networks, is how can we kind of enhance the idea of using a network operating system on any box, having that disaggregated white box idea, also and bringing that into the routing environment. So the routing requirements for public cloud providers, for managed service providers, in order to kind of interconnect with public and co-location providers in a hyperscale environment, that has been kind of the task, and that is how we've all started off. We talked about I've heard a lot of these benefits around whiteboxing, open networking in previous presentations. Obviously, there's a strong touch for CapEx, right? I mean, you want to have a very cost-efficient, cost-effective way to use the hardware. But then obviously, we're pairing it in the open compute and the open source community in order to also reduce the OpEx space and make sure that we're open and we're boosting intelligent applications. So, by tackling one, by making sure you're going to use the whitebox approach, making sure you're going to have a CapEx efficient and setup, and pairing it with OCP, you'll basically hit the OpEx side as well. Now, if we talk about disaggregated networking, and I'm just level setting the stage here, this is kind of a typical stack you'll find. You'll find your bare metal switches, OCP compliant. You're running ONI, running the open networking interface on it in order to accommodate a networking operating system. So this is what it all started off. Software defined, sitting on top of it in a typical fabric environment, providing controller or controllerless functionalities, and all of that. Obviously, the advantage that's being given is you'll have full control over your network. You'll see what's happening in your networks. You'll get analytics. You'll get the telemetry, which you'll then basically through northbound interfaces, you'll either able to export these data to accommodate the analytics tasks around it, or you basically use management automation tools for your fabric. This is a pretty standard kind of stack which has been used, which many SDN vendors are currently hooking on. And here is the design, and this is basically where we all kicked it off in a standard fabric approach, the spine and the leaf core. Now, obviously, our goal has always been that spine leaf environment for us is kind of a heterogeneous multi-vendor environment. So spine and the top of the rack can be different vendor, different operating systems working on it. The question and the problem we had to solve is, how do you interconnect to your public cloud providers? How do you interconnect on a regional level to your ISPs for the north-south traffic? Usually that requires kind of high bandwidth pipes going up from 10 gig, well, usually now 100 gigabit Ethernet. And the challenge we've seen is that these devices and these boxes typically use custom ASICs are dedicated build, do not meet any Whitebox environment and requirements. And obviously, where they're customs built, hold a lot of memory and carry a lot of memory in order to be able to accommodate the entire internet routing capabilities. The question we've asked ourselves is that something which is really a key requirement? And customers have been telling us, no, we might not be, using that scale of the boxes. So the problem we've seen is these devices been very expensive, over the years accumulated thousands of features, obviously leading to complexity, leading to interoperability issues, consuming memory, and using custom silicon, locked-in silicon. And for us, kind of the goal was, if we were just using a smaller number of routes on a per tenant basis, how can we build kind of a dedicated solution in order to replace these issues? So, now I'm facing the same issue. So basically, we went the OCP approach, using an edge core architecture with a Broadcom Tomahawk chipset. We've been using a box with a bit more of memory, 30 gig of RAM, dedicated SSD, and what is important, and this is the OCP compliant design, we've been using 2 extra 10 gig high-speed lanes just for control plane, traffic. So with a powerful CPU, a x86 Xeon architecture. These two 10 gig lines, internal lines connecting to the CPU. We're having efficient lanes for all control plane analytics, routing, and firewall capabilities. The design is nothing specific. It is, as I mentioned, it is a off-the-shelf edge core box, but we've been basically using that design to accommodate that data center gateway routing functionality. So usually VRFs, if we're talking about the gateway functions, the way in order to provide multi-tenancy and to slice the customers, we're using VRFs. VRFs in the edge for the tenants, using that shared infrastructure, and on an L3 basis, which basically accommodates, and you're going to hit the limitations on the capabilities of the device. For the east-west traffic, typically VXLAN, VLAN segmentation has been used in order to isolate and provide multi-tenancy. Now, how can we accommodate, or how can we use a similar concept? And here is what we've been introducing is the vRouter concept to overcome the limitations VRFs are giving us. Our approach is to use dedicated containers within each container, running an FRR stack, an open source stack, for each tenant to provide that level of isolation within every container. What we can do is we can run multiple VRFs for giving you flexibility and security as well. So that is basically the approach to use a very cost-effective, using a Whitebox cost-effective solution, allowing hardware-based routing at terabit speed. And And here is basically what the design is going to has been looked like. Using our base, our operating system, our Linux-based operating system, the two 10 gig lines, and we're scaling up to 128 containers per boxes. So we're basically adding up 128 tenants. Within each tenant, we're running our own layer 3 routing stack through the concept of vRouters, and that has been providing full isolation amongst each tenant. We derive wire speed routing capabilities, and obviously through the container approach, we can use third-party virtual services for any applications like Wireshark, packet capturing, etc. The bandwidth, according to basically what customers have been asking us, had to be 100 gigs. So we've been stuck to the 100 gig capabilities in the one rack unit, and the orchestration automation SDN layer basically being on top of it. We've been using that stack coming from our existing software-defined controllerless architecture. So here is where we basically used an existing hardware stack in order to accommodate the capabilities, and we've been replacing the concept of the VRFs with what we call the virtual routers. The virtual routers really giving you the capabilities for a large number of routing instances, providing you the full isolation between data control and management plane between each tenant, making sure the north-south traffic has been accordingly routed to your respective ISP, to your respective public cloud. You do have we provide an API for orchestration for each tenant. So each tenant can explicitly manage and orchestrate their own environment. And it's basically an easy way to kind of provide that per tenant portal and orchestration layer. Now, how does that apply in a mixed public cloud environment? And how is slicing going to be derived? We're using the concept of both the VRFs and the virtual router, because within a virtual router now we can run multiple VRFs and basically use the traditional VRFs inside every vRouter, which gives us enhanced capabilities. So literally every container is going to be its own layer 3 stack, providing high scale, high slicing, high multi-tenancy capabilities in a classic data center gateway features functionality. One of the asks we've been, or one of the topics we've been looking into is, why does it have to be a dedicated router? Like, why does it have to be a dedicated hardware to boxes for resiliency? So supported already today is we've been taking the feature and the functionality set of the data center gateway router into the leaf nodes of our fabric. So we're having dedicated leaf nodes which can run both a leaf functionality within the fabric, but also provide data center gateway routing functionality into it. So the router now is not kind of an external device, but it's kind of integrated into the fabric and into the SDN concept. Whether it's in our case, this is a controllerless functionality. We're not requiring any controller, but obviously, here is the flexibility of the design. And here is basically the conclusions. What are we getting out of it? Why are we doing it? It's really kind of driving down the economics here, both from a CapEx, and I mentioned through using open source on an OpEx side as well. Through the tenant routing, we've been providing multi-tenancy and improved isolation, giving us a security functionality. Flexibility enhancements using FRR. So we can ensure that each tenant has the full freedom of provisioning, terminating its connectivity, managing its connectivity with no constraints, without looking at the other tenant. It's ideal for integration in any computing environments when cost, power, space is at a premium. So you can collapse the gateway into the fabric. This is what we've done, so we're not using it as an external device. And then obviously using it in a containerized methodology to have the routing instances be integrated from one physical box to another, opening it, kind of opening up the whiteboxing open networking idea for the whole topology here. So this is kind of a project which has been initiated by a cloud hosting provider down in Italy, and we've been taking it and kind of built that solution on it. Yeah, take a look. We've got a lot of kind of data references on it. We've been making this an OCP project together with EdgeCore. So we are part of the OCP networking environment through the EdgeCore architecture build. And you'll find a lot of information through our blog as well as in the data sheets. All right. Opening up for any questions, opening up for any comments. Yes, please.
When traffic goes from fabric to the cloud, is it going through the firewall or just?
So obviously, for us, it's kind of what is in between. Is behind the gateway router. So yes, it would hit the firewall, so you can have a firewall layer, and I think I'll have it in here. So basically, you would connect through your ISP and either before or afterwards hit the firewall layer.
There was a firewall somewhere. That one.
That one? Well, you know, but these are kind of the firewalls. These are the firewalls inbound to the data center.
I think he meant the firewall running into the Xeon.
Oh! I see. Oh, you mean this one, right? Okay, yeah. No, this is okay. I'll get it. So this is basically what we say is obviously you could run, because it is it's kind of a server. You can run third-party applications also on the device. So if that is what you want, obviously you would have to look at well. We haven't done this. We have not run it, but in theory, you can run third-party applications, Wireshark firewalls on it as well as a kind of a VNF on it. No, it is not. It is not a firewall. It is not. But basically, because it's kind of an open design, you could run VNFs as part of it. Yeah.
But then you're pushing all your traffic through those two 10 gig.
Well, yes, but that is kind of currently the 10 gig links. You'd have to kind of see architected whether that kind of hits a limitation. We've been using the routing capabilities in our existing deployments only. So you would have to look whether that is going to be the bandwidth the bandwidth limitation or not.
So if the routing, the rich stuff, is everything up there?
Yeah. Everything will run down on the ASIC. Yeah. Correct.
They are also limited to the fit, not just in the
correct. Yeah.
Since the interface between the forwarding plane and the control plane is 10 gig, do you have the possibility, if you wanted to scale that beyond 128, I guess you call them container view routers?
Yeah, container view.
If you wanted to scale that up and put like a large, powerful x86 server underneath the switch rather than using the embedded Xeon, or if it was like a less powerful thing with like a quad core Atom and a big server, is that possible?
Currently, we're basically the limitation we were stuck was on the EdgeCore architecture. So in theory, it would be, We've been trying to kind of accommodate it in a Whitebox environment where this design is giving us, and we've been kind of trying to leverage especially the 10 gig links and the capabilities with the existing CPU. But it doesn't prevent us, so we've been looking into it. I think at least from the target audience, the target customer really being the managed service provider, cloud hosting provider, the design is absolutely adequate. Obviously, if you've been looking into, what is that?
128 VRFs is adequate.
What do you think? Is it?
I've got 600 in my network.
Okay. So it's kind of the 128 V routers, not VRFs, and then you can run the VRFs within the V router. So you'll basically have to multiply that within the V router concept. Okay. So we have not, to be honest, at least in the scale we've been running into it, we didn't hit that scale yet.
You say you're running these separate V routers.
Yes.
On the data center side, you've got traffic separation using VXLAN.
VXLAN, VLAN, yeah.
How are you doing traffic separation on the internet side? Because obviously they're going to appear as multiple routers to the outside world. Are you running over different links? Or?
Yeah. Well, no. Well, we're running. We're using absolutely. This is why we're using the 32 port device, kind of always peering to dedicated service providers or hosters.
So each V router would have
dedicated links to it. Okay.
Can you go to the conclusion?
Yep.
Can you explain this, the false atom a little bit more, collapsing the DC gateway in the switching fabric?
Yeah.
What do you mean by that?
What I mean by that is, we've seen that the data center gateway router are dedicated devices, custom-built devices, which basically reside outside the fabric. What we've done is we took that feature functionality and we've included it into the fabric nodes, like into the leaf nodes with us. So basically making it part of the fabric, making it part of the existing environment, which basically means that I can reuse existing hardware instead of having to have two dedicated. Basically, you'll take a pair, you take a pod, and you'll basically have your interface or your exit to the cloud, to the service providers, integrated into the fabric.
Are you running those V routers in the fabric node, or you connecting to those?
We're running them in the fabric node. We're running them in the fabric node. We're not connecting. We're not only connecting to it. Good one. Okay. Well, that is kind of the design aspect. We've had customers asking for it. Then there are obviously pros and cons to say we want to keep them dedicated. But in theory, we can run them. We can bring them, reduce again hardware footprint on it. All right. If there aren't any, one more question. It's our own, yeah. So this is where we call it an advisor. It's a Linux. It's an operating system based on Linux, but this is kind of our own Pluribus Networks operating system. One more.
So with 128 V routers, like say on each leaf switch, what's the maximum scale of your orchestration or management plane on top of that? Because if you look at a pretty big leaf spine network and you've got 128 V routers on each leaf, that's a lot.
You mean how big is the
How many V routers can you manage right before it blows up?
So the theoretical number is 128. We're not scaling up to that yet.
Full control
Yeah.
ecosystem. Okay.
Yeah.
Got it.
All right. Well, thank you very much. Thanks for joining in.